Welcome everybody to week 13, day 1. We're going to be continuing our discussion of inheritance today, inheritance in C++, with probably the last talk on inheritance. It's a big topic. If you study Java, everything in Java is inheritance. You know, the language itself doesn't even allow you to make a class without it inheriting from something. There is one class that doesn't inherit from anything, and that is the Java Superclass, the object, capital O object class. Is it quality at 1440p or just me? I have it at 1080p streaming resolution. Learn GitHub. Brain is getting smoother every day. Yeah, learning GitHub is an important skill. It's pretty necessary. If you want to work on your project using GitHub, it's probably a good idea. So, I have posted an extra credit workshop on how to log in without using a password. And if you want to share an account with your friends, you're free to hand them a copy of your you can make a key just for them so they can log in as you without giving them your password. Of course, they could always delete all the files in your account, but at the same time, you would know who it is. So, seems like a reasonably okay endeavor whenever you collaborate. They can always just delete it. Because of the wallpaper, okay, I'll cover it up then. I do like this wallpaper. It's pretty cool. It's like got a kid drawing sharks here while sharks are kind of circling around. It's pretty cool. The name of it is Painting the Sharks 4K. It's got a clock action up here. All right. So, let's do more inheritance. Inheritomancy, the magical art of coding with inheritance. Like I said, other professors go a lot deeper into inheritance than I do. I teach it towards the end of second semester computer science simply because you don't need it, but a lot of companies use a lot of inheritance. You gotta learn it. You gotta be familiar with it. Great job interview questions come out of here. So, shark bait, forbidden magic, yeah. Except you have to know it. It's kind of like pointers. Like you can't really escape it. Like you have to know pointers. And if you're going to do inheritance, you have to know pointers because there's just through the way that the C++ is designed, it doesn't work with regular variables. Whereas in Java, since everything is technically a pointer under the hood, everything just kind of works nicer with inheritance in Java. In C++, you have to do pointers and smart pointers. And from what I understand, Zybooks was just teaching it with like regular pointers, which is like not recommended. You can work it, and people did it that way for years, but making a vector of smart pointers is better. All right. So we're going to be talking about the final keyword you're going to be learning in this class, which is final. There is no final in this class, but there is a final keyword in this class, and the final keyword is final. We talked about virtual override already. We're going to go over pure virtual abstract classes a little bit. You've already used them. You used them on the hash table assignment, but we'll go over them again. And then after that, we will be finally, exactly. After we do that, then we will talk about multiple inheritance and the problems with multiple inheritance and the solution, which is something called virtual inheritance. And okay, so just recap. The virtual keyword allows inheritance to work. If you do inheritance and you don't use the virtual keyword, at some point you're going to be baffled when it calls the base class case instead of the child class like it's supposed to. So you have to tag any function you want to have overridden. You need to tag it as virtual, and this has a performance cost. There's something called RTTI, runtime type information, and every time you got a pointer and you call foo on the pointer, it basically at runtime figures out what type it is. It holds up a mirror to itself. It says, "Oh, look at me, I'm a flying animal. I'm not a regular animal, I'm a flying animal." And then it calls the special flying animal override for the function. And there's something called a V table, a virtual table, that is basically a list of all the different overrides for whatever function. In this case, we have a function here called foo, but it's whatever function you've overridden. There's all of them in that table, and it basically looks at its type, and it calls the right function, and that's not the slowest thing in the world. In the bigger scheme of things, it's like an if statement. But for really small functions, the overhead of that can actually be quite significant, like maybe an 8 times slowdown in performance for something simple like a getter or a setter. And so sometimes like some people just make everything virtual, and then they just don't have to worry about it, and maybe that's fine. Like if your code doesn't run slow, then okay, it's good enough. But C++ has this issue, right, of like the default is fast and unsafe, and then if you want to make your code slow and safe, you have to actually type extra work for that. And so virtual is slower and safer because a lot of times you want it to be like you want B here to override A correctly. That's clearly what you're trying to do, but if you don't tag it as virtual, it won't work right. And so, people say C++ is a language where all the defaults are wrong. And there's a certain amount of truth to that, but at this point in time, like, you can't fix the defaults. So, so, like I said, some people just put virtual on everything, and then if they need to optimize it later, they might come through and figure out, okay, this getter really doesn't need to be overridden. And so we'll tag it as final, which we're about to learn in 2 slides. So basically on the base class, you need virtual. You do not need virtual here. Even if you override B in like a C, like if you do struct C inherits from B, and it overrides foo, it doesn't need virtual. When you have the parent method marked as virtual, all of the children methods will inherit the virtual tag from it. That said, a lot of people recommend that you just put virtual on everything, right? Like you could, you will find people that will just say, just do that, right? On everything. Everything that's virtual, just tag it as virtual, even though it doesn't do anything, so that when you look at it, you know that it's a virtual function. That's pretty common advice. My personal coding style is to do this instead, where rather than tagging B as virtual, I tag it as override. And there's two reasons why I do it that way. First of all, if something is override, it must be virtual. It must be. Putting virtual there does absolutely nothing, and it doesn't tell you anything. Because if something is marked as override, if it's got that tag on it, it must be a virtual function. And so virtual is just completely redundant at that point. If you've got the override tag, you don't need virtual. And to me, like I get why people say just put virtual there anyway, but it's like override means it's virtual. It's a virtual is literally a waste of typing space. And so one of my things is about human psychology, right? And when humans are reading source code, and source codes are for humans, you can do things like look at people's eyes and do eye tracking and see how people are parsing lines of code. Everything you put on the screen, the eye is going to look at. Even if you discard it, it slows you down. And that's one of the things that like people don't think about when they're debating STD : right? 99% of people will say put an STD : like in front of the cout here every time, so that you know that it is the standard library cout instead of who knows where that cout came from. And to me, it's like, no, it comes from stud. Like if there was any other cout out there, then I would definitely be like boost : cout or whatever. Definitely use those namespaces. Everybody knows that square root and pow and cout, they're in stud. Like these are very commonly known things, and you're accomplishing nothing but, again, eating up a little bit of your brain power, and your eye will skim around and it'll look at the stud : and just discard it. But it slows down the human interpretation of code, and that's something that I'm like a huge nerd for, or something. I don't know what the right word is, but like I try to optimize being able to look at the code and understand it quickly and cleanly, And having extra virtual there doesn't help. It's not something I feel strongly about. Just like the stud : thing. I don't. If your style guide, if you're hiring me as a programmer and your style guide says you have to put STDs everywhere, I'll give you all the STDs you want. It's fine. You want virtual in front of the thing, it's fine. It's not a big deal, honestly. It's really not. But just like when I'm doing my own, coding and things like that, I don't like writing things that do nothing. And because there's a cost. Even if it's a small cost, the brain still looks at it, processes it, discards it, looks over here. Oh, there's virtual, looks at it. Oh, there's an override. Okay, discards it. And that's just something I kind of nerd over. I will give you all the STDs imaginable. Standard library, Betancourt. Standard library. Okay, so the override keyword ensures that you are successfully overriding a parent class method that is virtual. Okay, and these things are easy to screw up. Like I didn't put the const tag here, so like maybe in the future I come in here and tag this as const. Like, oh, that's a constant method. I should tag it as const. And then I forget to change it down there. This will pick it up. Nope. You said you're overriding something and you're not. Okay? So I love the override keyword. I use it every time. Highly recommend using it because it ensures that the two things stay synchronized with each other. And that's something that I'm also really big on. You never want to make it so that if something changes in one place, something else has to change in another place. Because guaranteed it won't. People don't know, they don't have a complete view on the code a lot of times. And so by doing things like that, it'll find your mistakes and it'll tell you. And you're like, oh yeah, okay, I need to add a const there too. Done. It's very nice keyword. It's completely optional. Your code will run and compile, assuming it's correct, exactly the same way, but it just catches a lot of stupid mistakes. And I've made a lot of stupid mistakes. That's why all the STDs imaginable. No, I'm kidding. So basically every child class needs override on all the methods you're overriding. Okay. And by need, it's like highly recommended. You don't have to, but virtual on the parent class, override on the child class. That's how I code. Now, the final tag. Means that this thing cannot be overridden by anybody else. And it's not super useful because if you're doing inheritance, usually you want things to be inheritable by other things in the future, and it's really weird to be like, I know that in the future I will never need ever again to inherit off this thing. You just can't know that usually most of the time. Like you just don't know. But that said, it's an optimization that you might be able to get some dividends on. So it's in the language. Like I said, I don't think I've ever used it myself. I use it in Java, I guess, public static, final, whatever. In Java, the final keyword means something a little different. But in C++, Basically what it means is that if you have this function here tagged as final, if you inherit from B into a class called C, then you can't override this function. That's all it means. And it's a bit odd, like maybe you do want to override it, but Would you put the parent class in its own .h file and the child class is in their own .h files? Yeah, you can do it that way. Depends how you want. Depends how you want to do it. You can put them in the same file if you want, or you put them in different files. Just depends. Organization of code's one of those topics that you can really kind of argue back and forth on. You can also make an entire class final. So you can say struct b final : A. And you might notice that I don't have the public here. The reason why I don't have the public here is because when you do struct inheritance, it defaults to public. Classes default to private inheritance. So it's less typing for me on a slide. So we have here struct b final A, and then that basically makes everything final. And like I said, not super useful because like at some point you're going to probably be like, yo, I do want to inherit from that thing. It happens. But as an optimization thing, you might need to do it if you need to make your code faster. Or buy a faster CPU, either way. So let's come on to here. And let's talk about, let me just show that, I guess, struct A. We're doing inheritance, we have to do animals, it's just the rule. some completely contrived example like this. So if we do this, if we make it an animal of type flying animal, we call the fly method on it, prints out this flying code. If we call it on bird, what will it print? Okay. So got flying animal Bob, flying animal Cindy. We're passing Bob and Cindy to flap one at a time, which we'll call the fly methods on them. What is it going to print out? For Bob, what's it going to print out for Sydney? Castillo, Mitchell, McCurley, Garcia. This is flying code twice. Yeah. Just lost GDB. Right. And did that because you're not virtual. Be virtual there, and then it works properly. It overrides it correctly. This one needs to be override, of course. Override doesn't do anything. Oh, if I spell it right, how about that? There we go. It doesn't do anything if your code's correct. But it does help you if you, like if you forget to make this virtual, right? Something's marked override, but it does not override because you didn't mark it as virtual, right? And then I can mark this as final. And then it'll say virtual function is overriding final function, right? So the bird function is trying to override a final method. Can't do it. Okay. So final says you can't override me. Okay, makes sense. You guys understand? I'll put it here. Fine. This one's fine. Unless we're going to override bird with something. Wow. Alright, let's talk about pure virtual. So, pure virtual was used in the hash table assignment. It's actually a good example of it. Much better example than the stupid animal examples we always use in computer science. It's always animals and shapes. I don't know why. So here we have what's called a pure abstract, pure virtual class, an interface. There's different terms for the same thing. And what it is, it's a class that has absolutely no code whatsoever. If I ever tried making a variable of type hash, if I said hash h like this, it will not compile because there is no code. It's there. All the code is missing. That's what the equals 0 means. There is zero code here. All right. So, is closed source libraries a thing? Final. Yeah, it's not. It's not a security measure, right? Like it doesn't. You know, you can always, like if somebody publishes a library and they don't give you the source code for it, whether or not you marked it as final makes absolutely no difference. The code will compile the same way. There are optimizations that can be turned on. For example, if you pass something of type, whatever the base type is, or the child type is, it can actually turn off the vtable stuff if it's marked final. But when you're passing the base class, like, it makes no difference really because it still has to do it. And if you're given like a compiled library, yeah, it really doesn't matter if it's final or not, because people can't really inherit from you anyway if the thing is closed source. They don't really have access to it. So, good question though, Carlos. So anyway, here we have something called a pure virtual class. So it's a class that has a bunch of functions in it, and the functions don't exist. You can't make a variable of this type because those functions don't exist. But here's the cool thing. Anybody who inherits from that class must implement those functions or they won't compile. Right? So if I were to come in and delete the remove or the search or whatever off of like linear probing hash, it won't compile. And it won't compile because if you're implementing the hash interface, you're basically saying, I'm going to do these 4 things here. I'm going to do insert, I'm going to do remove, I'm going to do search, I'm going to do change. Your destructor should always be virtual as well. Does that make sense? So like if I were to make my own class here, class Bob is going to inherit from hash, and I make it's templated. Let's copy and paste this real fast. I put the final there so you can see what that looks like. So, take care of that. So if we were to just override like 3 of them, right? Normally you can do that. Normally when you do inheritance, you don't have to override all of the members. You can override none of them if you want. It's perfectly fine. But if you have a pure virtual class, this is just saying that all of my children, everybody who implements the hash interface, must do these 4 functions here. And so if I make Bob and I say void insert, and these really should be const reference, shouldn't they? Just copy and paste this. Technically, you don't need the return, of course. I'm just putting that in there just to be explicit. There's just a little stub function here. And so what you'll find is that, and this looks cool and all, right? But if you ever tried making a variable of type Bob, then it gets mad, right? You can't do it because this doesn't exist. Okay, so you have to implement all of the, we already got another one. There you go. All right, so actually, it's a great bug. Let's do that. So why is this line not compiling here? Yeah, all right, you already got it. Yeah, it needs to be a bool, right? I marked it as override, but I didn't type it exactly correctly, right? This needs to be bool, and it will pick that up that you didn't have the right signature, right? You said you're overriding something, but you're not, and so there's all sorts of those little stupid little mistakes you make that can be very frustrating to find and fix. That oh, this still won't work. Do you know why? This still won't work. Do you know why? Not this. I mean, yeah, it's good catch, but virtual is void. Virtual functions can be void. It's fine. Const. Yes, very good. The search function is a const method, so this needs to be const, right, for it to work. Good. And so basically, every time you inherit from hash, you must implement these 4 things. That's what a pure abstract, pure virtual, or interface. It's 3 different ways of saying the same thing. That's what it's for. And this is how you do it. You just make a bunch of functions in the base class, set them equal to 0, which means they don't exist, basically. And then in all the child classes, you override those 4 things. And then when you come into, let's see if this is going to work. Did I copy and paste something? What happened here? Did I duplicate something? I think I might have just copy and pasted a huge amount of stuff. Okay. There. All right. Linear, chaining, third. Oh, that's about right. Okay. There we go. All right. So in main, two chains. That's right. The destructor, yeah, destructors need to be virtual, or things break. You'll get a warning from the compiler if you don't have a virtual destructor. All right. So here in main, you can see how this is actually used in practice. And the downside to inheritance is that inheritance basically forces you into using pointers. Sometimes you can get away with just references, but a lot of times, if you want to make a variable that could be one of the different subclasses, you have to use a pointer. And the reason for that is because you can't make a variable of type hash. It just doesn't, you can't make it. It doesn't exist. There's no code. And so what you have to do is you have to make a hash pointer. All pointers are the same size, 64 bits on a 64-bit system, which we have here, 32 bits on a 32-bit system. And what you do is you new a child class, linear probing hash, chaining hash, whatever, and a parent class pointer can hold a pointer to any of the subclasses. That's the magic that makes inheritance work, but it forces you into using pointers, which a lot of people find scary. So the Zybooks had you using raw pointers, which I wouldn't do it. It seems like a bad idea, especially vectors of raw pointers, which is just a terrible idea. And so here we have a pointer to a hash table. That's the base type. And you can't make it, so it's just null, right? You can't make it. You can't make a new hash, right? It's just, it'll be null. And then you say if the mode is linear, you call the make unique function. Make unique is like new, and so it's going to new a variable of type the child class linear probing hash, and it returns a pointer, and that pointer can be held in a pointer of the hash type. And if you put in something else, it makes a chaining hash, and it returns a pointer. And then down here, all this code is the same. So when you call table points to change, what happens is it calls change. It holds up a mirror to itself saying, who am I? Am I a linear? Am I chaining? Am I double hash? Who am I? And it's like, oh, you're double hash. It's like, okay. And then it looks it up secretly in the V table and calls the double hash change function. And so all this inheritance stuff is to avoid an if statement, right? Who am I? And if, okay, I'm this one, then do this one's insert or search or delete or whatever. Yep. So multiple inheritance says permission denied. Yes, it is secret until I unlock it for you. Okay. Yeah, but what's nice is that it allows us here in main, like, we don't have to know any of the details about how the hash table works. Is it linear? Linear is very different from chaining. Is it calling the standard library version? Who cares? You know, you just call table points to search, table points to insert, and this is using that interface in hash.h. That just pure virtual interface. It just says there's 4 functions that are guaranteed to exist, and it's going to call them change and insert and search and remove. All right? You guys see how that makes it kind of nice? Right? You don't have to, like, main, past this point, up top here, main doesn't need to know anything about the implementation details. As long as the interface is the same, the details can be swapped out under the hood. You guys understand? Pure virtual interfaces, pure abstract. Yes? No? Yes? Okay. Alright, so let's talk about multiple inheritance. Sounds like it makes sense. Well, I mean, you did it already and it made sense. Okay, so let's say we got here flying animal and birds are flying animals. We don't need you anymore. And let's make, not just a bird, let's make a pelican. And let's also make a type called swimming animal. And pelicans are both flying animals and swimming animals. Ta-da! Okay. Cool. So you can actually inherit from multiple classes at the same time. And this is very common in the Java world, or if you're working with interfaces like those pure virtual things, then what you can do is you can just inherit that interface, and as long as you implement it, then any function that takes that interface as a parameter, your code will work with it. And that's how like Java does things like their countable interface. No, comparable. Sorry, comparable interface in Java. It's a pure abstract class, or an interface is what it's called in Java. And basically, as long as you implement the compare_to method, then you have successfully implemented the interface. And this is how they sort things. This is the equivalent to operator less than in C++. So any object that has a compare_to method on it implements the comparable interface, you can pass it to sort, essentially. You can sort a vector of them, or whatever. And so, in Java, it's quite common to have a class that inherits off of multiple interfaces, serializable and comparable and things like that. And that just says there's this certain functionality, these functions, these names that do these things. I have done them on my class. And then your code will just work automatically with serializers and with you make a vector and just sort it, things like that. It's quite nice. And so this is in C++ how you do it. And if you're doing classes, then you'd have to put public, there as well. Are you going to make the inheritance public? Yeah, it's a struct, and so it's less typing, which is nice. Now, it's all well and good if I compile this. Let's see. So burb fly, swim, swim. So you can see that it has overridden the flying animal method on the pelican. So it calls that one successfully. That worked right. And then we don't have any override on the swim for pelican, but who cares? We're just calling the default swim method, so it prints out swim, swim. Okay, cool. Now, here's a problem. Health and location, something like that. And so let's say that swimming animal inherits from animal, and flying animal inherits from animal. So that means all the swimming animals, it's like we did this, right? It's like we did this, right? You just copy and paste the code in, right? Yeah. Those are the seagulls, Aaron. That's not the pelican from Finding Nemo. Nigel is the pelican. All right. And so when we did flying animal, it's like we did this, right? And then when we inherit from both of them, it's going to copy and paste both of these into pelican. So we're going to have 6 variables instead of 3 in Nigel. Okay. Checks out. The compile's fine. But if we ever do this, if we ever try like printing out Nigel's health, it won't compile. And the reason why it won't compile is because there's 2 of them. Nigel actually has 2 variables named health. It's got one from its flying side of things, it's got one from its swimming side of things. So if you really wanted to, you could do this flying animal ::health Nigel.swimming animal ::health is equal to 10. We can initialize these if you want. And we can get rid of X and Y, who cares? And so Nigel actually has 2 different health bars. Yep. Autocomplete, please. Thank you. And so there's probably not what you expected, right? It's probably not what you expected. Pelican inherits health from both sides of its family, so it has 2 healths. Like, what? Like, huh? that's a thing, yeah, and you just treat them. You can access them like this using the scope resolution operator, but it's probably wrong. It's probably not what you expected. It's probably not what you want, right? One health bar for the air, one health bar for the water. Yeah, I mean, if you really, if that's really what you want, you can do that. Now, it's probably not what you want, though. And so you might say, well, clearly the answer is to make this variable virtual, right? Nope, can't do it. Unfortunately, that is not allowed. You cannot make a virtual variable in a class. What about final? Well, final's not going to happen. Right. So the way you resolve this is through something called virtual inheritance. Before we talk about that, let me just say this is a terrible thing in general. In general, this is considered what's called an anti-pattern. It's considered not good practice to have diamond inheritance, and it's called diamond inheritance because your family tree looks like a diamond. It's not good. If your family tree looks like a vertical line, it's a problem. Okay, so if you have class A and you have B inherit off A and C inherit off A, and then class D inherits off this is called a diamond pattern for inheritance, diamond inheritance. Okay. And so if A has health, then B has health, right? And C has health. And D gets 2 healths, because everything inside of both of them are copied and pasted. Okay? So, this is really, this is like, no. In general, you just don't want to do this in general, right? But it happens. It does come up. Aaron was pointing out earlier that Unreal Engine has, it's not good in real life either. Yeah, true. Right? So in general, you kind of not want to design your classes in such a way that you're multiple inheriting like this. That said, it will happen at times. So the solution is to do what's called virtual inheritance. Virtual inheritance involves you slapping a virtual here and a virtual here. And now you just have Nigel.health. Voila. So when you do virtual inheritance, it will merge both healths together and work. Basically, by putting the virtual keyword there, then it works the way that you would expect it to work. You might ask, well, why don't we just put virtual with everything? Well, because there's a cost, right? And C++, the default is to be fast and unsafe, and you have to type more to be slow and safe, and I would prefer it if it defaulted to virtual and you would have to put a non-virtual. I don't know, whatever. In general, you shouldn't be doing diamond inheritance anyway, so. Multiple inheritance is okay. Like I said, especially when you have interfaces and things like that, like, you can have like a, kind of like what C++ or what Java does. But you can inherit from multiple things. That's usually fine. It's not a big deal. It just copies and pastes all of them in. But when you have two things inherited from that both inherited from the same thing, it causes issues, and you resolve those issues by just putting virtual there. Okay. B inherits from A, C inherits from A, D inherits from C, B, and A. Okay. Yeah, we can do that. There. Like that. A lot of typing. A lot of typing to get the behavior that you want. I don't know if the order matters. Let me check. Yeah, it's fine. But you can put them in any order. A lot of typing, yeah. Yeah, and all that typing is because, like, if you talk to like an experienced C++ person, there's a lot of things that basically you should always do, like mark const methods as const, right, and mark virtual methods as virtual, and yeah, okay, it doesn't. This one's override, yeah. But like, there's other things like no except, right? Yeah, whatever. Where does that go? Here. No. Yeah, so there's a no except tag that you can add on things. That means it's not going to throw an exception, and there's just so much boilerplate code that people just do by default. Everything const reference, it's an extra, just. Yeah, yeah. If you look at like just the default signature for like a, I mean, look at this. Yeah. It's ridiculous. Like, this is how. Yeah, I mean, look at. I mean, I don't know. It just gets dumb, and that's the unfortunate. That's the unfortunate reality of C++, is that the defaults are all bad. So, yeah, you just have to fix it in post-production. So it's... goes after the function. So the yeah, because they didn't have no except on the child class, they got mad at me. Basically, this function can't throw an exception, so it should be tagged as no except. So, yeah. A lot of typing. All right. So let's talk about. Let's talk about. Yeah, I think it's good for inheritance. Let's talk about the RPG assignment. If anyone needs a partner, remember, please post. So here we got this. All right, you guys. There. So inside of the public directory, there is a multiple inheritance guide. You can look at it. So you can see here, we're walking around the world. Down here, it's updating the X and the Y location, and that takes place through not a cout statement. It takes place through mvprintw, which is an incurse's print function. So that's the that's what we're going to be talking about in a second here. So the way that incurses works, to do this whole nice, beautiful full screen stuff, and GDB, by the way, has a G. -L incurses. This should be compiled with clean. GDB. GDB has a curses mode. I don't know if it actually uses curses, but called --2e, and then that will actually have your source code here, and you can set breakpoints and things like that. Like I don't know, set a breakpoint on line 47, break line 47, You can see you can hit up arrow and down arrow, and so you can see the source code, and then you run the program. And then it's running the program, and then I'm going up, down, left. But when I hit right, then it triggers the breakpoint. Control L refreshes the screen, of course. There I am. I can say print X and get the value of X. There's a way that I don't remember off the top of my head. You can actually set on the right-hand side of the screen here a bunch of variables, and as you like step through it and things like that, you can print. What is map size? Okay, it's 100. Okay. What is X? X is 49, and you can step line by line through your code. It's really nice. And so TUI mode is really nice for GDB. And then you can, once you're done with that, you can hit run again. Sorry, continue. And then it keeps running again. It's control. There you go. Yeah, it doesn't work great with another incurses app. But that's GDB using incurses or something similar. So, incurses mode works immediately. You don't have to hit enter. Normally when you do a CN double right arrow, it will wait until you hit return for anything to happen. Right? Is there an incurses function that tells you what tile you're standing on? No, that's your code. Your code is, it's got a variable called X and a variable called Y, and that is the tile that you are standing on. So what is L incurses? The incurses is the thing. -L means use the incurses library. So that links in a library called incurses. And I don't know why I have curl in here. That's an odd thing. Am I using curl? No, I'm not. Weird. System clear. If system clear. Shut up the warning. Thank you. Warnings go away. Go away. Okay. Good. So normally when you do like a CN double right arrow into a string, right? And it gets there, it just pauses your program. And then you can sit there and type. And you can erase, and type some more. And then nothing happens until you hit return. Right? When you hit the enter key. Nothing happens until then. It pauses your program. And with incurses, it will, it is for bridges, but we don't need it for this assignment. I don't know why it's in there. So, and so what happens with incurses is it doesn't wait, or you can set it to not wait. And so right now it's set to not wait any longer than 10 milliseconds. So when you ask for input, it will pause for 10 milliseconds, and if 100th of a second. And if you haven't typed anything in the meantime, it just returns error, which is not an error. It just means you didn't hit anything. And so this allows you to do immediate things like use arrow keys and page up and page down and stuff like that. It's pretty cool. So this is very different from CN and Cout. It's immediate. Okay. And here's how it works. You have to visualize. Oh, that's right. Yes, yes, yes. Thank you. That's why it's in there. All right. You have to use bridges. Right. Yes. It's not being used right now, but it will be. Yes. Thank you. Thank you for reminding me. Okay. So if you want to switch back and forth between incurses mode and using CN and Cout, like for a battle or something like that, you can do something like this. You can turn off incurses, do your CNs, Couts, whatever. So this goes, it's going to read a string, print it, pause for a second, then turn incurses back on. So that's how you can kind of go back and forth between using cooked mode, which is what you get with CN and Cout, and using raw mode, which is what you get with incurses. So here we go, down, and then when I hit up, it switches into CN, it's pausing, nothing's running. I do that, it prints it to the screen, waits a second, then goes back into incurses mode, and we're right back where we were before. Okay. Now, a very common question I get in this class is, how do I know what's on the map? Well, by default, the map thing has no ability to access what's on the map from main, right? If you open up the map, The map has a 2D vector that holds all the characters in the map, but it is private. You cannot access that using the from main. So you need to write a getter and a setter. Hey, look at that. So something along these lines, like it will return a char and called get, I don't know, thing, get, char, get, I don't care. Okay, x and y location. So you pass an x and a y location, and then you return map.at y.at x. Y is rows, x is columns, so y actually comes before x. Remember that. And you can do the opposite for set, right? So you pass in an x, a y, and a character, and you write it in that location. And this would be very useful. In fact, it's pretty much something you have to do. What does the file you stored your map into look like? I think I messed up my save function. Getting my world file looks weird. It just looks like a text file, and it just reads each character from the text file. It's just 100 by 100 text. Okay. So that's something like that you need to do for a getter and do the opposite for a setter. And then in main, you're going to use that like when you run into things, right? So when you are trying to move, this code here says if my new location is different from my old location, right? So you're moving. You don't need to do this on every frame because you're idle on most frames. You can do something like this. So you can like get the if the spot you're moving to, x and y is the spot you're moving to, old x and old y is your current location. So you can get the location you're moving to, and if it's a treasure, then you write open into it. So you pick up the treasure and increase your money variable or something. There is no money variable, that's why it's mad at me. And there is no getter and setter because I deleted it, right? But that's a general idea. Something like this. Yep. Something like that, right? So you pick up the treasure, and if the spot you're moving to is a wall, then you don't move, right? You set, like something like this, like if else if map.get xy equals map wall x equal to old x, y is equal to old y, something like that. So you bounce off the wall. Simple. Yeah. So you do that for wall, do that for lakes. For treasures, you pick up the treasure. For monsters, you're going to switch into a fight screen. If it's open, you just move. Yeah. It's a general idea of what we're going for here. How do you set an event to happen on a char? Something like this, right? So you have to write a getter from the map, and then when you can put special characters in there. If you look at the map.h, you can see that there's some consts for each of the different things that are in the world, but you're more than welcome to add your own. In fact, you probably should. So you can add like spotlights and houses and things like that. And when you walk over it, then you turn off incursive mode and have a dialogue with somebody, whatever, and when you're done, turn the incursive mode back on and continue with the game. Okay. That's my advice. Now, sometimes you don't want to do that because it looks kind of weird. It clears the screen and kind of looks very awkward and it's not very professional looking. So let's say you wanted to print something on the screen without clearing it, right, and without dropping out of incursive mode. So let's say I wanted to print on the screen at row 5, column 40, something. I like mudkips. Okay? So this is how you do it in incursives. mv print w, move print w. So it's going to move the cursor to row 50, column 40, and it's going to print I like mudkips there. Okay. See that? 5 rows down, 40 columns to the right, I like mudkips. And no matter how I move around, you see how this doesn't mess with the screen like cn and cout do. if you see in and see out things, those things, the see outs are going to appear wherever the cursor just happens to be at the time. And so they cause all sorts of problems when you use see out with incurses mode turned on. It's highly not recommended. If you want to print things to the screen without dropping out of incurses mode, MV print W is your friend. And if you want to print out variables, this is how things are done in SeaWorld. There's this format string kind of thing here, and this says print a variable of type integer, print a variable of type integer, and it reads the variable values from here. So that's reading the x and y value and printing them to the screen. I tried to set a constant char to a Unicode char and got an error about overflowing a char. Yeah, I wouldn't necessarily want to work with Unicode. I don't know how good incurses support is for it. So that's so you can print things to the screen. If you want to get different keys, this function here, this is the heart of incurses. That function there will pause for 10 seconds, 10 milliseconds. And if nothing is returned, then it will be error as a return. And we might even put this one first. Whatever. Okay. And then, yeah. So if they don't type anything, it returns ERR, right here. If they hit up, down, left, or right, it's going to return up, down, left, or right. If they type in page down, page up, insert key, home key, end key, that kind of stuff, there's all sorts of options for those as well. All the F keys, things like that. And that's why it's returning an integer here and not a char. Okay. The get function returns an integer because ASCII only has 127 values. And there's a lot more keys that can be hit than the ones that are available in ASCII. ASCII has uppercase, lowercase letters, the basic symbols, things like that. And it's got a bunch of wasted things here, like the cancel key and device control 4, which I don't know, nobody ever uses. But you might notice, like page up, page down, things like that, they're not on here. And so if you want to know what all of the different options are, and like if you want to make your code work with like page up and page down, for example, then if you open up this header file, incurses, locate it. Okay, there you are. Oh, that's the one that uses Unicode, incurses W. That's right. Okay. You open up the file, and then you search for, like, page down. Keyboard down. Home down. Key LL. Lower left key. Arrow down. Arrow down. Search for page, maybe. There we go. Next page key, previous page key. So that's the number that gets returned. End page and P page, I think. Backspace, home, right. Okay. So all those extended key options are available in incurses. Just look up the documentation, or link up the header file, really. Is there a clear screen command? Yeah, right here. So that is the curses command to clear the screen. And yeah. Clear the screen, turn off incurses mode, and then that clears the system screen too, as well, just in case. Will characters from other languages work in incurses? Maybe. You might have to use incurses W, the wide character support. Is that how you did /s? Oh. Is curses clear pretty slow? I don't think so. It's probably pretty fast. It's pretty well optimized, I think. It's probably just a single VT100 escape sequence sent. So it's about this many characters. I don't know how they do it exactly. W clear, stood screen. So there's a function called wclear. And I don't know how it's implemented. That's why you have to link the incurses library, and I don't have the full source code to it. Is that how I did \SL? Yeah. I didn't make that. That's a standard Unix program. But yeah, probably something like that. Flying a railroad. Okay, so yeah, that's basically lolcat. Okay, yeah, that's basically incurses. It's incurses in a nutshell. That's an important function. If we look at the map here, you can see that we have printing one character. So mv print w prints a whole string. Mv add sh is the same as mv print w, except it prints one character instead of a whole string. But the basic idea is the same. You give it a row, you give it a column, you give it a character to print. And in curses, you can do things like turn colors on, like this. I have six colors defined, one for walls, which are red, heroes white, water's blue or cayenne or whatever. So this turns on a color, this turns off the color, and then it prints the character in the map at that location. For the hero is not actually on the map. The hero just gets drawn always on the map at whatever the X and Y location you give it. And it turns on underlining and bolding for the hero, and then it prints the H to the screen rather than whatever's on the map normally there. And then it turns off underlining and bolding. If you don't do that, watch what happens. So if we don't turn off the underlining and bolding, you can see that it prints the hero, and then underline and bold is turned on. You can see the dots are a different color, right, as before, and they're all underlined like that. And then if we start moving around, just everything becomes absolutely horrible. So yeah, you turn on underlining and turn it off when you're done with it, and everything works right. These colors are set up in main. So in main, it sets up 6 colors. Incurses does not support RGB color. Like, you can't give it a 255, 255, whatever 0, for, full red, full green, no blue. My colors library does. And so if you want to use my colors library instead of incurses, it does support 32-bit color. Incurses does not. So there's that. Is there a website for incurses documentation? Does incurses work with my colors library? No, my colors library is basically a complete, from the ground floor up, different implementation of a lot of the stuff that incurses does. It's just easier to use, I think. So you don't have to use incurses at all if you don't want. Yeah, there is documentation for incurses. There's a good, probably have in my bookmarks here. Website is down. Oh, there used to be a good tutorial on it. Looks like the I guess this will work here. Okay. So source code. Yeah, Dickey's the guy who makes incurses. He wasn't the original author on it, but he sort of took it over after a bunch of drama involving Stallman and a lot of other people. Eric S. Raymond. Eric S. Raymond used to work on incurses, and man, that thing exploded. All right, source code, tables from the book. Let's see, source code. Okay, where's the actual book? You have to buy it. Do you really have to buy it? You don't actually have the... The old version was available for free. Source code at least is available. So you can go on here and look up, how to do things, I guess. All right. Incursus drama. Yeah, seriously. It's So Eric S. Raymond is one of the most famous guys in the open source movement, and Stallman is the biggest person in the free software movement. Those movements are not the same, despite sounding the same. And so here's all the different people that were involved in the drama, and you can see there's timelines of events, and I will post this on Discord, and you can you can read that at your leisure. Does it have to have a group of heroes? Yes, you must have more than one hero. You must have a party of heroes. It's one of the requirements in the README file. It's the whole point. There's no point doing initiative when there's one monster and one player, right? So you need to have a bunch of players and a bunch of monsters, and sort them together into a circularly linked list that is the turn order, and then you just use that as your turn order, and then visualize it on bridges. Yep. And the good news is you're given a working circular linked list. So just adapt the code here, and when you're done, call visualize, and you're done. Okay. Any other questions about incurses? There's a lot to it. Like it's a big thing. You may just find it easier to use the colors library. Basically, yeah, you can just set the colors using RGB values. You just set the color, and then whatever you see in and see out, or see out, I guess see in doesn't matter. Whatever you see out will just have that color for the background and have that color for the foreground. Just RGB values, and just use see out for everything. That's fine. It'll work fine. This resets the color. This gets how many rows and columns your screen is. This moves the cursor to row and column. So you can say move cursor to row 5, column 40, and then see out something. And so it kind of works just very smoothly with just regular see outing and stuff like that. Can the heroes fight a single monster at a time? They have to fight a group of monsters. You must have a group of heroes and a group of monsters. Yes. There's no shortcuts in life, except where there are shortcuts in life. This clears the screen, turns the cursor on and off, right? So right now, you can see the cursor on the screen, but you can turn it on and off. You can support mouse functions. You can make callbacks that when they click, it'll do stuff. And then this tells you how many bytes are waiting to be read. And quick read is the that is the equivalent of getcha in incurses. So basically you call quick read, and if there's data available, it returns it. Also as an int. And if it's not available, then it returns err, just like incurses. So this basically does the same thing. So you just call quick read all the time, and you just get, and it'll give you arrow keys, and it supports all the function keys on the top of the keyboard, stuff like that. So I wrote the colors library just because incurses is kind of this giant thing that has to be statically linked and things like that, and I realized there's just a way easier way to do it, where you just use see in and see out and change the colors and move the cursor and just do it that way. So, is that the one? The incurses programming how to. Okay, yeah. Yep, that's a thing. It's all very C-like, you know. All this stuff is really, you know, you got pointers and options that you're gonna bitwise OR together and stuff like that. Yeah, it's up to you. Okay, that is it for today, everyone. I will see you on Wednesday. Get cracking on the RPG assignment if you haven't already. It is a 20-point assignment, and it is a pair programming assignment, so it counts more than your regular homework assignment. So absolutely, under no circumstances do I want to see anybody getting a 0 on this assignment. Okay? It will not set you up for success in the class. Let's put it that way. All right. See you guys next time. Peace out.